We're going to begin our electricity unit by talking about electric current. Before we start, though, I want you to take a moment to try to define electric current on that box on the top of your notes. You use electricity every single day. What do you think electricity or electric current means? All right, I'm sure you have an awesome definition written down. Let's see how close you were to the real thing. If you think about our energy unit, we defined electric energy or electricity as energy from the flow of electrons. That flow of electrons is what we call electric current. As electrons travel through a wire, they are going to move, and it is that moving of the electrons that gives us electricity. You notice in both of these pictures we have the tiny electrons traveling past the larger protons. This is electric current. There are two types of electric current. There is AC and DC current. Let's start by talking about DC current, direct current. In direct current, the electrons flow in one direction, always the same way. They're going to flow from the negative to the positive. From the negative to the positive. Same thing here, coming from the negative side of the battery right to the positive. It always moves in one direction. That is our key about direct current, is one direction. Anything that is battery powered is going to have this direct current. Our second type is alternating current. In alternating current, the charges flow in reverse directions. Watch here. This is using water as an example. You can see that sometimes right here has the dots, and other times it is here that has the dots. It's changing directions, sometimes going this way, sometimes going this way. This is alternating current. When you look at this diagram, traveling, look at the arrows flip one way to the other. This is alternating current. The battery in here has no play. We're not using this battery at all. The circuit covers right here going to the AC generator. Anything that is in the walls of a building is alternating current. Direct current is battery. Alternating current is normally in the walls and plugs. The last things we need to know is the difference between conductors and insulators. In conductors, material flows very easy. Things like metals, water, anything that gets hot easy, or if you touched it with electricity running through it, you would get electrocuted. That is the example of conductors. So the middle of the wires here, those metal parts of the wires, those are conductors. The opposite of that is insulators, material through which electricity cannot flow easily. Our insulators are this outside material. Can you think of a couple different types of insulators right now? Good. Hopefully you've said something like rubber, glass. Sorry, that was a very bad G. Okay, anything that doesn't get hot, doesn't allow electricity to go through it. Maybe plastics. We coat wire in rubber because we don't want someone to be able to touch the wire with electricity running through it and get electrocuted. And we don't want that electricity to jump into the walls, maybe start a fire. So we coat things in rubber. We coat it in an insulator. Alright, that's it for this video. Hopefully you have learned in the video about what is electric current, the difference between AC and DC current, and the two terms of conductors and insulators. Make sure you have all of those things in your notes.